In this video, we're going to learn how to make what the part that we call 9 of 24. 9 of 24 is over here. What makes this part unique is the fact that it has vertically positioned items, which are these circular entities here. I'm making circles using my mouse, so yeah, they don't look very good at all. Okay? And then you have an angular face, a face that is literally at an angle. These objects are sitting on an angled plane, and that angle is 15 degrees right there. So here they start out vertical, but they connect to an angled face. Also, we realize that this dimension here, from center to center, this dimension is 3 inches. From this position here to this position here. That's a vertical height of 3. The entire shape is 2.5 on the depth, but not necessarily this angled piece. We see that this angle is at 15 degrees. We see that this height is at 3 degrees. So if I did a front view representation of this, here's that blue part, here's the red part. This inclusive angle from here, from this position to this position, is 15 degrees. Actually, I'm going to draw it on the other side. This height is 3 inches. Okay? This defines this part. If we build it with this in mind up front, everything will lockstep fall exactly where it's supposed to be. So when we go over here in SolidWorks, we're in SolidWorks 2018. I scooch that over just a little bit. There you go. SolidWorks 2018 is what this says. File new. Started as a part. Always we do the same thing. We turn on our planes. Make sure they're all on. And we think to ourselves, how should I build this? Yeah, there's more than one way. For today, I still say there's a tried and true method when it comes to building shapes like this. The first thing you should always do for yourself is build a scaffolding. That's what I call it. This represents our scaffolding over here. So it's always a good idea to build that reference into your drawing. This is in what perspective? What view would we find this in? The front view. That's right. This is what our scaffolding looks like from the front. This whole thing. So if I go into the front view, I'm going to draw this scaffolding. I can draw it as solid lines or as a center line. I don't think it's going to matter for the purpose of what we're using it for. So I'm going to make it center line. So there's my 2 lines. I cannot change their colors. They are what they are. I'm going to draw that vertical line. It's going to be a 3-inch height. And this angled line will be the 15 degrees. See that? That's it. That's our reference. This is our scaffolding. I'm okaying out of this This is going to be what we're going to use as our base. Now, in order to draw this shape, let me change colors back. In order to draw this shape back here, that I'm outlining as I'm saying it, I need to be at 15 degrees. Now pay attention, you see how I highlighted the front? That's what we're building. So when we extrude back. Remember that, we extrude back, away from this. Otherwise all of our math is off. So now we're going to add, just back up for a second. Remember, we can only draw on a plane. We can't draw in space. So we have to have a plane where we're going to draw. So I need to add a plane to where I want this object. Now, I can add my plane two ways. I can pick my right plane, and then I can pick my little angle. And you see what it did? See how it angled it? I don't want that. What I really want is what? If I pick parallel, that's physically impossible. Parallel doesn't work. Why? The right plane and that line are definitely not parallel to each other. I have perpendicular, which is what it did. I have coincident, which I can't do because they can't be coincident to each other. That means they share the same point. And then I have angle. See that? That doesn't work either. I have this object here, but if I pick that, that's another plane, then what happens down here? Now it gets upset, it can't do anything. See that? Error, rebuild error, constant rebuild error. Nothing works in any of these features. If you look at all the elements, there's line 1. I've got this, a line, and the plane as a reference, so that doesn't work. So if we go back, we ask ourselves what might work. If I go to reference geometry, pick plane again. Let me pick this object, I'm going to pick this object, and then I pick my little angled line. Ooh, look at that. Okay, I picked my right plane, I picked my top plane, and then I picked my line. I can try perpendicular, no. Coincident, definitely no go. Project, no go. That doesn't work either. Angle, no, because I don't know the angle. Notice that? So even though I picked these two planes, now I will tell you this, the lesson of this particular exercise is when you pick two planes, you're not getting the angle you want, which is this angle, but you will get somewhere in between those two planes. And that somewhere in between is 45 degrees. Cool? That's a quick way to make a 45 degree line, but we don't want a 45 degree line. We want a line at a specific angle, so that's a no-go. So now we ask ourselves, okay, let's try one more thing. Plane is annoying. See this? When I go into plane, if I pick this, and see how that does offset, see that? If I pick this reference, it wants to align itself to that face. It doesn't want to be coincident to it, parallel to it, angular to it. See, none of that works. You have to actually, of all things, put in a axis, a reference axis. If I put one here and here, see that axis? I'll be okay. This axis now, if I pick plane, in relationship to that axis and this line, did you see that? It picked that spot dead on. Let me X out of that again. The key is an axis. If I take this axis out, I can't pick this setup at all. It will In other products it does, but not in this product. The other way you can do it is you can go to View, Hide Show, and turn on temporary axes, but I don't think, we don't have any temporary axes to turn on, to be honest, because there are no objects in this drawing. So there's no temporary axes here. We have to add an axis, not a plane, sorry, hit the wrong one. We have to add an axis related to this right plane and this top plane. Notice which way the axis goes. That's going to be our hinge, just like the hinge on a door, the door hinge. Now when we go into axis, now when we go into plane, it automatically picks the axis. It knows you want to do something, so it picks the axis automatically. When I pick my reference geometry, that guy right there, boom, see how that angle's immediately there? I don't have to do anything else. It'll automatically go there. That is the way inside SolidWorks to assign that axis. When you do it this way, and I go back to my sketch, and let's say I want to edit my sketch, and I want to change my angle, I don't know, 30 degrees just for fun. And okay, out of this thing, notice what my plane did. It went lockstep with it. Okay? So my sketch, what my customer finds important is my backbone to this thing. Whenever I change this information, it updates where my plane goes. That's how I control that plane. The alternative method of doing all of this, if I wanted to, I'm going to roll this back a little bit to the original spot, is I put a plane. I still have to put an axis in no matter what I do. I still have to put an axis in because it needs that. When I add in my plane, it automatically selects that and then selects this. But I'd have to specify the angle from there, like 30 degrees or so. Well, not 30. So that works. You see that? Even though the angle is showing down here, this is very similar to the first or the second part we did in class with that piece that looked like a chair that was off at an angle. That's how we did this one. Yeah, that one bracket where I did a flip and a flip. See that? Remember that? That works too. And then, but I'd have to go edit this thing. I'd have to remember to edit this plane there to control its angle. See that? Whee! So those are the two ways to make this thing. One is to use this method. The other is to actually draw this reference geometry for yourself. I don't care which method you use, but whoops. Let's make sure we do have to make sure that the angle is correct though, which I don't have right now. Is that correct? Let's roll this puppy down and see. Yep. Oh, good. So whichever method you choose works just fine. Just be aware that there's more than one way to do it. All right? Next, I want to draw on this plane. So I pick that plane and I go ahead and sketch on it. You do want to pick normal too, so you could look at this head on. You might want to turn your other planes off because they are visually challenging. I agree with that. So in this plane, what's this? That's the top plane. So I'll visually turn that off. Now I can draw this shape. Now, these are aligned with each other. This is aligned with this. So they're in plane with each other. So I can just go ahead and draw a circle on this axis over here. I can just go ahead and draw circles here. and draw a circle related to this spot right there. See that? That you would not get if you drew it the other way. If I drew it the other way and just put a plane in without my triangle, I wouldn't have that quick of a finish here. The only reason this was so easy to lay out was because you see this end point over here that this locked into? There was an end point to lock into. There wasn't if I just used the plane method. That's the other reason I recommend using this method right here. Because then I have an anchor, a place to go to. That's my advice. In fact, when you check the dimensions here, you're going to find out that it's not 3. It's some other number. And the reason for that is, when you look over here, if the height of this is 3 inches, which is what this height needs to be, the hypotenuse of this triangle right here, the hippopotamus, whatever name we want to give it, see this blue angle line? Has to be more than 3. Can't be less than 3, and it can't be equal to 3. The hypotenuse of a right triangle can never be the same length as either of its sides. It's physically impossible. All right? Every day of the week, I can go build it using 2x4s if I want to. Doesn't matter. It's physically impossible. You will see that that's how it works. It's a beautiful thing, I like to say, that you can do that. Now the dimension from here to the center, what is this dimension? And the rest is just measuring, putting in your dimensions. This guy, I could pick this, and I say okay. These two are not locked to each other, remember that. They're independent. What was I going to say? Now, what's missing? A bunch of things. Let's draw our lines. One thing I will say to you, this method that I use over here that you're going to see me use, where I just draw lines out in La La Land for making lines tangent to circles, that is the least painful way to draw. I always recommend you do that. Making lines tangent to arcs is very, very difficult. So I usually say draw the lines outside somewhere. Remember, like we did the arc for the fan blade project? Draw the arc somewhere else and then make a tangent. That's what you want to do. That's how you want to set these up. Okay? I wouldn't recommend struggling with, let me make that. No, stop that. Just draw the line out in La La Land and bring it back. Again, you pick the line, hold your control key, pick the circle, then pick tangent. That's how you lock them in together. Pick the line, pick the circle, tangent. Cool. Okay, out of it. Pick the line, pick the circle, tangent. Okay, out of it. Pick the circle, pick the line. Notice, but in all cases, I'm holding my control key to get them to connect together. Now you can tell these are way off base. Let me see if I could fix this.
What happens if your circles move?
If they move away, if they move out, that means they're not constrained. There's something that's not constrained. So now I'm going to trim off these insides. And you can always try to connect everything together before, like you'll notice up here, I haven't really assigned any dimension except the 1.25. Now I'm going to turn around and assign my dimension of radius of 0.875. Wow, that's coming out wrong. Hold on. 0.875. Now it's going to be right. I did 0.875 because it says radius 0.88, typical, which is probably 0.875, 7/8 of an inch. Because that's this dimension right here, 0.875. Now I do want to take this dimension, hold my control key down, not the dimension, the radius, pick this arc here, radius or arc, pick this one here, and make them all equal to each other. And that way they're all the same size. Now I just have to find out what wants to move. Whee! This wants to move. Uh-oh, that's no good. Do we want that moving? Nope. I want that to lock down. Why doesn't it lock down? I want that to, it'll lock down to this, but it won't lock down its endpoint. How do I fix that? What should I do? If I haven't shown you this tool before, convert entities. It's your friend. You pick convert entities and you pick that dot. And you say, okay, guess what it did? It brought it forward into this sketch, so now I can lock it. Come on, you. I guess I'm going to have to hold my control key down, pick my point, and pick this point, and make them coincident. And hit OK. Now it's locked in.
That's coincident.
Coincident means I share the same point. Literally. I'm bound together in the same spot. Coincident.
Research.
Yes.
I have noticed that you use a lot of convert.
Yes.
Why do you really does?
Because I'm lazy. Convert entities, that's the real reason why I use it. It allows me to bring sketches from another part or another piece of my part that I'm building and reuse them in a current sketch. So in this case, for example, I have an existing sketch back here. Let me roll this back. Well, I got to get out of this to do this. I have to roll this back. I have my axis. Okay. I've got my sketch. See that beautiful sketch right there? And my sketch is dimensioned. See that? It has a 3-inch dimension on it. It has the 15-degree reference to it. See all that? See that? That's all in there. It's all good. Then I've got, I think the second axis came in when I was giving you that option B or something. Or it could be this one. Let me delete that one and see what happens. Something got deleted. We'll see what happened. We'll learn. Okay. There's my sketch 1. There's my axis 2. If I roll this down, there's my plane. So when I deleted that other sketch, what happened? It literally deleted this sketch right here. Because this one is using axis 2 and axis 3. Oh well. That does happen, so you have to be careful what you delete. Here's my sketch here. Here's my plane. This sketch here, the reason it was so easy to lock this down, because I carried over my endpoint from my original sketch, sketch 1. I carried it into here. So I didn't have to rebuild anything. I don't want to do the math to figure out what that hypotenuse is when I already built the shape in my other sketch. So I'm borrowing that sketch, a piece of it, into this drawing, into this sketch. That's why I use convert entities, and I will use it a lot. It allows me to use the object better, the objects that I've built. So now I have my shape. It's dimensioned and locked in properly. I'm going to edit this one more time to make sure I didn't miss anything. It is fully defined, so it's ready to roll. When I go to features and I go to extrude, this piece is important because depending on how I built my part, I will need to either extrude forward or backwards. Now the way I built this piece at 1/2 inch, see that? If I go forward, will my math be correct anymore? No, because my 3-inch mark is where? Back here. See where my 3-inch mark is? My 3-inch mark is based on the face of this. Face of it, not the back of it, the face of it. So I must extrude in the opposite direction in order to get the right dimensional data. Now when I hit OK, that's what I get. Everything will work now. The next set of steps, anyone want to guess? What do you think I'm going to have to add next? And another plane. Because now I gotta work on these front face features. I need this 2.5 inch dimension figured out. That item right there. Okay? That's back here. So the way I'm going to do that, I'm going to turn my plane, my right plane on. I'm going to make that visible now. But first, I'm going to go ahead and create a plane. See, I want to jump forward, so I'm going to pick that back edge, so that way it jumps back there. But I want it to be what? I want it to be a what? Parallel. Do I want it to be parallel? Do I want it to be perpendicular? What do I want? I'm going to X out of it so I can pay attention to thinking about. I'm going to pick my front plane, my right plane, and I'm going to pick my back. What do I want? Do I want something parallel to it? See, if I pick my, see how I pick parallel first? Then I pick my back edge? See how it comes out correctly then? Before, one more time, the first time I did it, I picked my right plane without thinking, and then I picked my back edge. So it went perpendicular and coincident, because those are the options it picked. When I pick parallel, bingo, then it flips up. I want it to be coincidence, of course, that back end point, but I need it to be parallel. I don't have to pick an angle, I can, but parallel is good enough. So be mindful of that. If you start messing around with this one, bingo, now I get my errors. See that? So I have to remember to pick coincident and parallel, and I'm fine. Now I know you want to just say, hey, now that I'm back there, why don't I type in 2.5? You can't. Just like before, I've said before when we create planes, it's a monotasking operation. I can't multitask this plane creation. I can only make one plane at a time. I hit OK. And now I got to go back into plane to do the next plane. And that one, the distance is 2.5. Not 3. Just try to type in the correct number. 3 times the charm. There you go. 2.5. That's where I'm building my plane. I hit OK. Voila. Here's that plane, 2.5 inches away from my back plane. Now again, we're getting a little too plane heavy, so I think we need to turn some planes off. Because they do fight us. When you have too many planes and you're looking at them all, it becomes visually challenging. So now it's plane 4 that I'm going to work on, which is the face of this part. And on this face, I'm going to create a new sketch. And again, you're going to find me doing convert entities. You're going to see me pick these arcs. Because when I do that, watch what happens. And I hit OK, boom. Isn't that beautiful? They move themselves forward, so now I can utilize them to make my objects. I will do one more thing before I do anything, and I want to make sure these are all for construction. So that way they won't fight me when I want to make something. See that? I turned everything for construction. They gave me all the reference geometry that I need to build my part, my next features. And they're going to be these guys. This one, and this one. Same deal. I'm going to go ahead and pick all 3 of them and say equal, so they all come out the same size. Remember that. How did I do that again? Remember how I did that. Hold your control key down and click on all 3 objects. They all appear, hit equal. I like this method faster than, I don't want to cancel. Faster than the following, which you might hear to do. You might hear go, add relations, and then pick the objects. I don't have to hit 2 steps. I'm too lazy for that. I just pick my objects and hold my control key down. That's the more efficient way to do it. Then I can go ahead and type in my, whatever my diameter is. What's the diameter? 1.25. And it locks them all in together. And now, just like a previous drawing we just did, I'm going to go to the side view. Now when I go to Features and Extrude, and I say up to Surface, and I have to pick my surface. I got to tilt that over a little bit. Pick my surface. Voila! You get what you want. See that? A beautiful matchup. Done. Hit OK. The next step is counterbores. Now remember, in SolidWorks you must pick the face first. In SolidWorks you must pick the face first. In SolidWorks you must pick the face first, then go to Hole Wizard. That is the KISS method approach to putting in holes inside SolidWorks. I don't want, what do I want? Counterbore. I don't really think I can use the default settings, so I'm going to use Legacy Counterbore. That way I can control every single dimension. The through diameter is 3/8, 0.375. The depth is through, so I don't care about that. The counterbore diameter is 0.875. The counterbore depth looks like, I can't really, I'm just going to say what it shows, which is 0.37, because I can't see if it's anything else. And that's it. Then I go to position. To position in the center, you kind of have to, there you go. You see how you kind of touch the sides a little bit? And then it finds the center. Touch the sides a little bit, and then it finds the center. And then it finds the center. And that's it. You hit OK. You're done. Those are your counterbores. The last thing you do want to add in, though, is that weird rib in the back. And I agree. It's definitely not clearly identified. I would build it off the front plane, to be honest, in my opinion, of how I would build it. And I would actually, of all things, draw it off on the side. The reason you want to draw it off on the side is so it doesn't lock into anything on the surface. Because it has some pretty specific dimensions. This dimension, for example, right here. Stop that. Okay, let me try that one more time. This dimension right here is 1.23. All right? This dimension here, it says 3. All right? FYI, that's what it says. Now, if I did, now it says 1 point, to be honest, I will, it says 1.23, but it doesn't necessarily tell you from where. I just assumed, and we all know what assume stands for. So if I take this and I take this, do you think they'll marry up? No. Collinear? No. I get ketchup and mustard. Yeah, it won't work. Now, one can argue, well, that's because this thing is parallel. If I took that off, smack, there it goes. I don't think it looks like that. But did you hear the way I said that? I don't think it looks like that. You're going to have to get that verified with the customer. Well, definitely that can't work, because this does have to be what angle? Complementary. This angle is 15 degrees. If it matches up to the side wall, saddles up to it vertically like that, in a beautiful way, it has to be 15 degrees. It has to be where did you go? Get back here. It has to be complementary to this body. If the 3-inch line is vertical. Now, because it's vertical here, see this? I'm going to make a serious assumption that it's vertical here. Okay? So, then in the back of your head, you should be scratching it going, well, then what's the 1.23? Well, the 1.23 maybe is from this back wall to this point, we can always draw it, and the customer can verify it. But now it's like, well, okay, if we do that, but it's not touching the part. Well, you can pick this angled element, you can pick this back wall, and you can make them collinear, which lines them up to each other. If we do that, ooh, we get a slight error. So what's its problem? What is its malfunction now? Let's delete the, okay. That's what it didn't like. Notice that? We had the 15 degrees in there. You'll notice you didn't get a full-blown ketchup and mustard. You only got ketchup. That's what I call it because it's yellow. Okay, that's the only reason I call it ketchup and mustard. In this case, we only got ketchup. But I wanted, I'm sorry, hello, we only got mustard in this case, not ketchup. You see? Some days, man. Recorded for life. We only got mustard, and the gosh darn it, you workers, I wanted ketchup. But this is a Chicago-style part. No ketchup, right? There's my bad joke of the night. All right, at least, I had 9:30. What do you want? All right, that's 9:20, sorry. Whatever it is, that's 9:15. Anyways, so if I take my mustard out, not my ketchup, hello, then it's fine. It's no longer upset with me. Cool? I think the reason it actually was upset with me is that 15 degrees and making it collinear mathematically mean the same thing. Because the angle of that face is at 15 degrees. That is why you're getting that error message. Because you're basically being redundant. You'd think it would say, hey, dude, you want it to be, driven or something? No. It's going to give me mustard. So we're going to get rid of that. All done. And this is the shape, the closest we can get based on the information we have available to us. This is the item that now we go ahead and extrude. We're going to pick midplane. And the thickness that they give us here is 0.31. And that's it. Everything the customer will have to verify anyways. So they'll have to confirm that that's where they want it. Now, if you look at the back wall, you will find out it's not flush. It's a little off. See that? So it's not flush to the bottom. If I go to the side view, it's a little off. I don't know what its function is, but it might be, who knows, negligible. I don't know. Maybe the customer doesn't care. They just want a backbone on it because, I don't know, for support. I don't know. Correct, you cannot. So the customer has to tell you what they want. Say again? Yeah, it could be something else. I don't know. But that's what we would build based on the information we have available to us. And then in the end, you have something that looks like this, and that ends this video.